What is up? Daniel here with the Virtual Robotics Studio, and we're back, finally ready to get this thing up and running, all wired, all built. So in this video, we're going to go ahead and initially set up all of our devices, and then run the Swerve generator to get our code, and then get the robot running. But before we get started, we have to give a special thanks to Argosy for making this all possible, and our product sponsors, Cross the Road Electronics and West Coast Products. And also thanks to our hosts here, Team 302, Lake Orion High School. All right, so before we get started setting up our devices and getting our program built, a couple things you'll have to do on your own before we get started. The RoboRio has been updated, so I put the new firmware on it. We're going to be working with the 2025 beta version right now. Obviously, if you're doing this after kickoff in January, you can just use the 2025 actual version or whatever the latest version is. Same thing, I have my radio programmed. We have one of the new Vivid hosting radios. That's programmed and set up with a team number, as well as the RoboRio. So make sure you get those things set up before we get started. And then the other thing I'm going to do is we're going to go through and we're going to, when we run the generator, we're going to have all of the wheels kind of moving, but we don't obviously want to drive off the table. And I think the best thing that you can do for this too is you just want it up on blocks so that nothing is going to actually, like the robot's not going to drive anywhere. And that gives us time to sort of work on stuff and figure out what's going on. So if I kind of just prop this end up, and 2x4 seems to be a pretty good height for this chassis, but if you have something bigger, of course you can go and grab something bigger if you need to. And once you've got that in, do make sure that it's not anywhere close to where your wheels are going to be spinning. So just kind of make sure your wheels are clear on all the sides. Last thing you want is for the board to get knocked down and then the robot takes off. All right, so that looks good. We'll go ahead and power up the robot now. And then on your computer, the next thing that you want to do is run the Phoenix Tuner X software. We are running the preview for 2025 again because it is pre-season. So this is the version for 2025, but it's still maybe got a couple minor updates that will happen before the season starts, but nothing that's going to affect really what we're working on now. All right, so once we're in here, we need to connect to our robot. There are a couple of different ways that you can do it. You can either plug a USB cable from your computer into the RoboRio, or if you have the radio set up and the connection stuff working, you can also run the driver station software. And we'll let that go. And we can connect through the driver station. Okay, and then once the driver station runs, if you haven't, make sure you have it set up for your team number. I think I set my robot up to be team number 3 because that's a good number. And the last thing is connect to your robot's wireless network. So there is FRC3, going to connect to that. Obviously, if you don't have the radio set up or have any issues with this, just go ahead and plug a USB cable directly in, and you're going to be all good to go. OK, so in the Tuner X software, the Phoenix Tuner X software, there are a few things that we can do. First thing is if you are connecting by driver station, kind of hit the 3 lines down here at the bottom. You can choose from driver station. If you're plugged directly into the RoboRio, then you can choose RoboRio USB. That's the other option that I use a lot. But we're doing driver station, so that's good. And then the next thing you want to do, you might have a different screen that pops up. Mine popped up 2 devices here already. But if you don't have any code on your RoboRio already, you'll probably have a different screen that's showing. And we kind of want stuff on that screen. So I'm going to go to Settings. And if you look for FRC Advanced here and open up FRC Advanced, you can run a temporary diagnostic server, which might be an option on the screen when it opens up again if you don't have any code on your RoboRio. So I'll go ahead and click on Run Temporary Diagnostic Server. And that's going to basically let us communicate and control all this stuff on here without needing any program on the robot to do that specifically. And that might take a second to pop up, but when it does, we'll be ready to go. All right, so we have success. Temporary diagnostic server is now running. And it's going to say reboot the device to revert. That means when we're done using the temporary diagnostic server, and you want to go back to using your robot with whatever code you normally have on the robot, you need to reboot the robot to get that code, or at least reboot the RoboRio. All right, so we're just going to say OK. All right, so the first place I'm actually going to go, I'm going to hit the menu. I'm going to go to Canivores. So we have the one Canivore that is running our CanFD bus that is controlling all of the devices for our Swerve. And I'm going to update that device first. So if you go to the device, if you click on it, on the side, you'll have a bunch of options. But we're looking for where it says, mine says 2024. Yours might be a different version. If you used it last year, it's probably 2024. If you never used it and it's been sitting around, maybe it's older. If you just bought it and it's brand new, it could be 2025. But we want to pick 2025, and then underneath that, you can choose the latest version. So if there's anything newer than 25.0.0.0, pick that when you're going to do this. And once that's selected, you can choose Update Firmware. This is going to take a second. And there we go. We get on the bottom, successfully updated firmware. So I guess, what, CanIV version 1.1. OK, cool. Looks good. So that one's all set. Then if we go to the menu and go to Devices, what you'll see is we see some of our devices, but not all of them. So we know that we should be seeing 2 motors per module. We have a steer motor and a drive motor for each module. And we have a CAN coder for each module. So we should be seeing 12 things here plus the pigeon. So we should be seeing 13 devices here. And we only see 3. There are a couple of possible causes for that. The most likely, and I think what's happening to me, is that we have just too many devices that are all device ID 0. And it's just going to show us a few of the device ID 0. So as we go through and we start giving them different device IDs, the rest are going to pop up. It is possible, too, that you have a wiring issue on your robot. So first, let's go through and change the device IDs. The next step then would be to go through the robot and make sure that all of the yellow wires are connected to yellow wires, green wires are connected to green wires, and making sure that you have that 120 ohm resistor at the very end of the whole CAN chain. All right, so let's go back in. Let's start changing IDs. And the way we're going to do it is, first, we have the pigeon. This one, I guess if I click on it, we get some options over here. And you might see different stuff on the right-hand side. There are different windows that you can bring up. Don't worry about that. We're just going to be working on the left here for the most part for right now. And one of the cool things is if you click the blink button, that is going to make the device that we're currently looking at blink on the robot. So we can see on the pigeon here, we got that kind of buried in the middle of the robot. But on the pigeon, we've got like this slow blink. But when I click the blink button, which I'm doing right now, you can see it starts flashing much faster and then goes back to its normal flashing pattern. So normal flashing pattern, I click the button, and then you see it's going crazy. Now, for the pigeon, not super important because we only have one pigeon. So we know the pigeon is the pigeon. But that's going to be super important when we got to figure out which like Kraken motor we're looking at of the 8 of them, or which CAN coder we're looking at of the 8 of them. All right, so let's go ahead and update our pigeon here. Since we're in it, we'll go to 2025. Phoenix 6 looks good. And I'm going to choose the latest version. So that looks like 2502. But again, if there's a higher number than that, you should pick that when you're doing this. All right, we'll click Update Firmware. A little progress bar. That's nice. And we're good. All right, then up here where the ID is, this is where everything needs to have a unique ID. If we have a bunch of devices at ID 0 and we tell ID 0 device to do something, they'll all do it or they'll get confused. So let's change this number to, let's think about this. We're going to have 8 motors, and we're going to have 4 sensors. And I want to kind of use those starting at 0. So we'll have 0 up through whatever as those devices. So this needs to be 13 or higher. So let's set this to, I guess 12 or higher. We can set this to 12. And then you click the Set button. And you'll see the device ID change to 12. And when we go back now to the devices page, you can either do the back arrow or you can go back through the menu to devices. It's green. The border is green now on the pigeon, which means it is updated. It is running the latest firmware. We can see in the corner it is ID 12. Also, incidentally, I think you can click on this little light here from this screen to make the device blink as well. All right, so that one is now updated. there is another way to update stuff. We can actually do a bulk update of everything at once. So what I think we're going to do is go through and set the IDs and rename all of our devices, and then we can do that bulk update so we don't have to update every device individually. All right, let's go to, I guess let's do our motors first. So I'm going to click on the Talon FX over here. And you can actually see, once we get in here, it actually tells me there are 8 devices with this device ID, and there is a firmware update available. So we're going to fix those things. We're going to do them one at a time. First, we have to figure out which one we're actually working with. So we're going to hit blink, and then we're going to have to look at all 8 motors and find out which one is blinking. They also will beep. The motors will beep too. All right, so that looks like, I think it's this one over here. I can see the lights going. So that is, if you look at the top, if the gears, right, so this gear, drives this big gear in the middle, that means this is the propulsion motor or the drive motor, not the steering motor. You can kind of double check that too, because if you take the wheel and you roll the wheel like it was driving, that motor is spinning. If I rotate, kind of they both spin, so it's harder to tell that way. One of them will spin more. But the easiest way is if you roll the wheel, the one that's spinning, that's the drive motor. The one that's not spinning is going to be the steering motor. So we know that was drive. I said the front of the robot in the last video was where the battery is. So let's see. So if this is the front of the robot over here, this will be the front left, which means the one that was blinking back here is back left. So that's our back left drive motor. All right, so in the software, we can do a couple things. First thing is, I'm going to do the left swerve modules first. So I'll do left front as 0 and 1, left back as, well, I guess 0, 1, and 2 for the camcoder. Left back will be 3, 4, and 5. So that means we want this one to be number 3, ID 3. And you can choose whatever order you want to name the things, as long as you can keep everything straight. You might want to make a list. I like to go left of side of the robot, front, then left back, then right front, then right back. But some people will do that differently. Some people will do both the fronts first and then the backs. You could do all of the drive motors first, and then all the steering motors, and then all the camcoders. Just however you want to keep it organized. But another cool thing is, I'm going to click set on 3 here. Another cool thing is that we can also change the name. So down here, this is Talon FX version whatever. We can actually go in here and we can remove some of this, or all of it, and type in whatever name we want. And I think this was back left. So I'm just going to do back left. And this was the drive motor, not the steering motor. So I'll do back left drive for this device and click set. And there's a good chance we might get one of these wrong, but there are several places where we'll be able to double check what we did. So we're going to go through once, get everything spread out, and then we can go through again and make sure no mistakes were made. All right, so that one is done. I'm going to click the back arrow to get back to my list of devices. And what you'll notice is now we have our back left drive on CAN ID 3. I can blink it again just to see. Yeah, it's the same one. But what's cool now is we have another Talon FX, right? We have another basically Kraken showing up here. So we'll click on the new Kraken, and it still says, hey, there's still 7 devices with this ID, and we know we're fixing that. Let's blink this one and see if we can find out which one is blinking. The beep is actually pretty helpful too, because it directs you to an area. So I think this one up here on the front. See, this one's a little bit easier to see, so hopefully we can see that blink pattern. All right, so we can see the lights down here and here, and when I click the button to blink, you can see it definitely goes into that fast blink pattern. All right, so we know this is the one that we're controlling. Again, I can tell this is going to be the drive motor again, because if I sort of rotate the front one back or follow the gears, we can see it. But again, if I spin the wheel, if I rotate the wheel like it was driving, that motor is spinning. So that is the drive motor, and that is front left. So this one, I actually want to be device 0. But if we leave it as device 0, it's hard to find the other ones. So we'll bring this one back to device ID 0 later. But let's just set it to something that's going to be completely out of the way. So I'm going to set it to 20 for now. There is a line of thought that says because all of the new devices show up as device ID 0, that skipping 0 and starting to use your actual devices from 1 and up might make more sense. So if you prefer that, start at 1. Just add 1 to all the numbers I'm using. But I'm going to keep going this way. All right, so let's also change the name like we did before. So this one is temporarily set to 20. We will come back to it later and make it our 0 item. But this is front left, and this is drive. All right, and I'm going to go ahead and click set for the name. And then let's go back to our device list once again. Once again, find the red Talon FX. We still have 6 devices here to deal with. And we're going to click the blink button and see if we can figure out which motor it is. OK, yep, and that looks like it's over here. And so that is also on our front left module. That is, of course, the steering motor then, not the drive motor. So we can go in here. That's going to then be number 1. So I'm going to do drive, steering, camcoder in that order for each module. So this is number 1. And we can click set for that. And then let's replace the name. So this is front left. I'll do dash steer for steering motor and click set. OK, and we can back out. Going to keep repeating the process. Click on the stack of motors again that are red. Still got 5 devices. Let's click the blink button and see if we can find where that one is. All right, I think that is our back left module again. So I've got this one here blinking. And so that's back left. That has to be steer because we already did the drive. So that's cool. All right. So I said the front left is going to be 1, 2, 3. Back left drive is 4. Oh, sorry, 0, 1, 2. Back left is drive is 3. Steer is 4, camcoder is 5. So this is going to be 4. So let's change our ID to 4 and click set. And change the name. This is back left steer. And set that. All right, let's back out. Click on the giant stack of red Talon FX again. And we're going to click blink. All right, I think that is back here. Yep. So that's this one. You can kind of see it here on the side. All right, and so that is the drive motor that we're seeing. All right, good. So 0, 1, 2 for the front left, 3, 4, 5 for the back left, 6, 7, 8 for the front right, which means we are 9, 10, 11 on the back. And that was, let me click blink one more time. That was this one, which is the drive motor. All right, so that means number 9, we'll set that. And rename it to back right drive. And click set. All right, let's back out one more time. Click on our motors. And blink it. All right, I think it's this one up here. Yep. Click the button, fast blinking. OK, and that is the drive motor. Cool. So front right. So we have 0, 1, 2, 3, 4, 5. So that's number 6. And we'll do set on that. OK, so we're set to 6. And we'll also change the name. This is front right drive. Click set on that. And back out we go. This is interesting. OK. We have 2 now. So it looks like there are 3 devices with this device ID running, and there are 2 devices. Well, let's find the one that's on CAN 0 and click on that again. And click blink. And let's find out which one that is. OK. Looks like that one is back right. So that one's this one back here. You can see it sort of even twitches just a little bit. So that is back right steer. OK. So back right steer is our, let's see, that's going to be 10, right? So 0, 1, 2 for the front left, 3, 4, 5 for the back left, 6, 7, 8 for the front right, 9 for drive, 10 for steer. So click set. And then we're going to say back right and steer, and set that. Back out we go. All right, we'll click on the device ID 0 again and blink that. All right, and that is hopefully our last motor. Yep. So that is this one up here. That is our front right, and that is the steering motor. Okay, and front right steering should be 7. And then let's change the name. FR steer. All right, and then we'll back out again. Okay. So let's see, we have no more devices. Oh, we still have the CAN coders. We'll have to do those. So we have 1 is front left steer, and then 0 or 20 right now, because we need to change it back temporarily, is front left drive. And then number 2 is going to be a CAN coder. 3 we have back left drive. 4 we have back left steer. 5 is going to be a CAN coder. So 6 should be front right drive, and 7 is front right steer. Makes sense. And then 8 is going to be a CAN coder. And then 9 is back left drive, and 10 is back right steer. Okay, so we still have some errors here of potentially multiple devices on the same ID. Let's set all of our CAN coders now. So we have the 8 motor set. We have the pigeon set. Let's set the CAN coders and then see if there's still anything that thinks it's conflicting. So click on the CAN coder stack. And again, we're going to do blink. These, unfortunately, don't make noise. So we have to watch. I think it was this one. Oh, no, wait. This one. There we go. Yep. So we click blink. That one's going. That is back left. So back left is going to be, back left is 3 and 4 are the motors, so 5 is the CAN coder. So we'll change it to 5 and click set. And then we will change the name to back left CAN coder and click set. All right, back out. Okay, we're looking for down here the red stack of CAN coders at ID 0. Click on that. Blink it again. Let's see if we can figure out which one's blinking. I think that's the front left one. Let me click it again here. Yep, that is the one that's going. So when I click blink, that one's going. That's front left. Very good. So that is going to be, so 0 and 1 are the motors, and 2 is going to be our CAN coder up there. So I'll change it to 2. Click set. Change the name to front left CAN coder and click set. All right, we got 2 more to figure out. So find the ID 0 CAN coder again and blink. I think we're here. Front right, it looks like. Yep. There goes when I click the blink button. Cool. So front right, so that is 6, 7, and so this is going to be 8 is the ID. So set that. And then we will change the name, of course. Front right CAN coder. All right, we have 1 more CAN coder. It's not going to be red anymore because there's nothing else stacked up there, so it's just ID 0. Click on that CAN coder. It better be the back right. Yep, so when I click blink, looks like we are good on the back right. All right, so we will go ahead and switch that to, let's see, back right. This is going to be 11. And click Set. And then we'll change the name to back right. Oops. Back right Cancoder. And click Set. We are just about there. All right, so now we have all of those set. Let's also change 20 back to 0 now, because we don't have none of these devices are showing up as 0. So we've done a good job of changing everything out. So if you find the device that's on ID 20, that should be front left FL drive. We'll click on that again. And we're just going to change the ID now down to 0, so it's in the order we wanted. And click Set. OK, so now we want to update all of our devices for real. And I told you there were some ways that we could do it all at once instead of having to click Update on every single one and wait. So on the device list, there are a few different ways you can do it. One way is there is this check icon up here, which is Select All Devices. That will select every single device, and then we can update it once. We're actually going to do that, but I'll show you a couple other things first. If you click on one device, like if we just want to update our Krakens and we don't want to touch the CAN coders, if you check a Kraken first and then click the check mark, it will select only our 8 Krakens. So the CAN coders here are unchecked and the pigeon is unchecked. So that way you can just update a certain type of device if you want. And another thing that you can be aware of is if you click these squares up here, it'll go to list mode. So sometimes it's nice to have the pictures to see what type of device it is. But scrolling down, if you have even more devices than this, sometimes makes it hard to see everything that's going on. So if you go to just the list mode, you can sort of see everything here and see what's checked, maybe a little bit easier. So we'll go back, though. Let's click the check marks to check all. You can see every single device is checked. And then let's click that up arrow to update all devices. And at the top here, we're using Phoenix 6, and we want 2025. So I'm going to switch it to 2025. And then when I click Update to the latest, it's going to find, remember I told you earlier, like I'm using 25.0.0. whatever. But if there's a bigger number, you should use that. This is going to pick the biggest number automatically. So just click Update to latest and let it go. And I think you'll get a little beep every time if a motor finishes updating. You get a little beep to let it know that it's now updated to the latest firmware. All right, that took a couple minutes, I think, maybe 3 minutes over here. I forgot to check what time we started. So it will take a little bit of time if you have this many devices. Obviously, if you have more devices, it will take even longer. But that's fine. Just be aware. It will take a few minutes. It's not going to be an instant thing. That's normal. All right, but we are in. We're ready to click the OK button. Firmware update completed. You can see a list of all the stuff. And yeah, that's everything. 4 CAN coders, 8 Talon FX on our Kraken X60 motors, and the Pigeon, which was already updated, but that's fine. Click OK. And then we can close down this window. And what you kind of want to see here is everything is green. You want to see green boxes, green outlines on all of this stuff. That'll mean that there's no conflict in terms of ID, and it is the latest firmware. So with that said, we are now ready to start generating our code to use the Swerve generator. So if you click on the menu again, the 3 lines on the upper left, we have a few other things that we can look at. We have the Canivore that we talked about before that we updated separately. That's here. I didn't rename that. If you have multiple Canivores on your robot, like maybe you have one just for the Swerve and you have another one for other stuff on your robot, I would recommend renaming it. Since we only have the one, I'm not gonna bother. Also on the menu, got kind of history, mechanisms, tools. So something that you might see in mechanisms is what we want. That is where the Swerve generator lives. And when you go to the Swerve generator page, there's a few things that it's asking you to check. So first, this is our pre-check. Our pre-check is, like, in order to be able to do this, you need to have 8 Talon FX or Talon FXS speed controllers, motor controllers here. because we need 8 motors, right? 4 drive motors, 4 steering motors. So you need to have 8 of those. And in order for the Swerve generator to work, it needs to have devices that are essentially cross-the-road electronics devices. That's what this is designed to work for. This is their software, of course. And that's the reason why we went with, the Pigeon for our IMU, the CAN coders, right, and the Kraken X60s, in addition to the fact that the Kraken probably is the most powerful motor that you can use right now. So because we're all cross-the-road electronics, we can use the Swerve generator. And we like the Swerve generator because this, I think, is by far the easiest way to sort of get your Swerve drive up and running. All right, we also need a Pigeon 2.0, which we've got. That's our IMU. Optional Phoenix Pro, that's OK if you have that or if you don't. Phoenix Pro will give you some additional features. There is, I think, a license fee involved with using Phoenix Pro on your stuff. This will work without it. I think it works a little better with it. There's some extra things that Phoenix Pro gives you that will make your stuff a little bit more accurate, a little bit more powerful. But if you don't have it, that's fine. And if you don't know if you need it or not, you might not need it then. When you think you need it, you'll know. Server version, OK, that's 2025. So we're set up for 2025. That's just matching all the stuff through. Obviously, if you did this in 2024, that would be 2024. If you're doing this in 2026, it will probably say server version 2026. OK, we need to confirm that there are 4 connected encoders. So we can use CAN coders, we can use PWM encoders connected to the Talent FXS, or other encoders connected to another CAN device. We can click the check mark. We have the 4 CAN coders. We set those up and gave them IDs and everything, so we're good there. Now, on the bottom, we're going to set some parameters. First thing is the wheel radius, not diameter, so make sure you don't get that mixed up. Now, this is the wheels that we have are, in theory, 4-inch wheels. So I'm going to go ahead and put 2 for the radius. You can always measure them. Sometimes with the tread on the outside, it's hard to get an exact measurement, and the tread may wear down a little bit. So like if I tried to measure one of these, let's see how close to 4 we actually get. They're also really hard to measure when they're in here. But we'll do our best. I think this way, maybe. Maybe not. This is really, really tough to get to. All right, kind of if we do this, we're looking at pretty close to 4. Again, I'm not perfect because I can't quite fit my calipers up in there. So barring that, yeah, I'm just a shade under 4, but I think I also didn't quite make it up to the end. So if you measure the wheels maybe when they're not in, that's something. Obviously, as you use them, the tread's going to wear down a little bit, so it might adjust things a little bit. But this is going to affect the speed that the robot moves, but it's not going to affect the steering and the angles that you move at. So it's OK if you have some bits of error there. And I think just leaving it at 2 is going to be OK. Next, we're going to tell it basically what is the shape of our robot. So this is asking front left to front right distance in inches. And so the question is, how far is it from the pivot point, essentially where, like if we look at the robot, where the CAN coders are here, right? That's the main pivot point where the wheels are going to rotate, or the rotation point where the wheels are going to rotate. So the question is, how far apart are those 2 points? And we can measure that with a tape measure. Chances are, if you're using the pre-drilled stuff, extrusions to connect the things together, it's going to end up being a whole number. Also, I think if you measure in CAD, you can get the distance from the edge of the robot to the center of that pivot point. So if you remember, this robot was 28 inches wide. And it's actually, I think, 2.5 inches from the edge of the robot to the pivot of the wheel. So if I take 2.5 off this side, 2.5 off this side, and then that's 5 total, we subtract that from the 28, that should give me 23. And if I measure them, kind of just eyeballing it, 23 looks pretty close. 23 is what I would expect. Probably using the CAD is going to give you slightly more accurate measurements than eyeballing the tape measure, but definitely double check it both ways. All right, so I'm going to go 23 inches here. And because I made mine square, this is now asking the distance. So this one was the distance from front to back on the robot. This is now asking from, this is front left to front right. So this is across the front, and this is from front left to back left. So this is along the robot. So that's basically the two different dimensions. And since this robot is square, it's going to be 23 inches again. If you build a non-square robot, you'll have to adjust that. And one of the things that this aspect ratio is going to do is if we tell the robot to rotate in place, we want to rotate about whatever the center of the robot is. So in my case, it's square, which means each wheel will turn. Technically, it's going to turn tangent to or the line going to the center of the robot, or perpendicular to the line going from the wheel's pivot to the center of the robot, which, because my robot's square, is going to be 45 degrees. But if the robot wasn't square, it would be able to adjust for that and change the angles of the wheels so you get a nice rotation point about the middle of the robot. All right, that's all set. So we have 23 and 23. Next, this is set up to do a lot of different, well, it's set up to do at least several different Swerve modules. And you can also choose custom if you're using one of the Swerve modules that's not listed here. You just got to go and find all of the rest of the numbers on your own. We're using a West Coast Products one, so I'm going to pick West Coast Products. And then if you click on this, there are a bunch of different choices for West Coast Products. The Swerve X2 is what we're using. That's the latest version coming out, I think, just about the time we filmed this, maybe a little bit before. And we're using the X2i, which is listed here. So it's just the X2 version with the inverted motors. So this says, basically, if we're using any of the Swerve X2s, pick this one. And then for drive ratio, we're going to click on this. And if you remember before, when we were building the modules, we got to choose a few different gears to choose our final gear ratio or final speed of the robot. So we had, the first choice was to choose a 14-tooth or a 16-tooth gear. If you chose the 14-tooth gear, that means you chose one of the X4 ratios. If you chose a 16-tooth gear, that means you have one of the X3 ratios. If you bought a slightly different kit, you might have X1 or X2. So you're just going to have to go back and figure out which one you picked there. Again, that chart we had showed in the video when we were originally picking the gear ratios will let you know. If you have this gear and this gear, this is your ratio, and this is the final thing. But X3 is the one we used because we used the 16-tooth gear. And then if you remember the next stage we had when we were putting on our drive motor, we could have chosen the 10, 11, or 12-tooth gear. And I said, I just want to keep mine as slow as possible because I'm just doing it in a small area for testing. So I chose the 10-tooth. So I know mine is going to be the 6.48 ratio. If you chose a different tooth count, make sure you choose the one, right, obviously, that you used. And if you are not using one of these default ones, right, you'll have to get your own ratio. You have to know your own ratio completely to fill in here. But I'm going to choose X3 10-tooth because that is what I used. And we're done. Everything is set up here. So we're going to go ahead and click New Project. If you already have some projects and you just want to redo the numbers and get some new constants and stuff, you can import and add to your project, or I guess view example, you can see what it's going to look like. But let's just click New Project. When you click New Project, now we have to go through and we have to validate everything. So this is a situation where we have to tell it specifically where everything goes. So it can't possibly know ahead of time what is the drive motor, what's the front left drive motor, what's the back right drive motor, what's the front left steering motor, which CAN coder goes with which module. We have to tell it that explicitly. So that's what we're going to go through here and do. So we have an option here to choose front left, front right, back left, back right. Let's just go in order. Click on front left. And over here, it says module configuration. Make sure it says front left so you know what is selected. And OK, what is the turning motor for front left? If we click the pull down, well, I remember like 0 was drive and 1 was turn. So I could look for ID 1, but also we named it, and that's going to make it way easier to pick. Front left steer is the front left module steering motor. All right, let's get the drive motor for front left. So that means front left drive is what we're looking for, FL drive right here. That is showing up as ID 20. So let me go back and make sure we actually clicked set when I changed that from 20 to 0 before we continue. So I'm going to go back to the devices page quickly here. And I'm looking for front left drive. And Oh, I see. I see. So it is set to ID 0, but when I changed the name, it kept the 20 in here. So I'm just going to change that and click Set again. And then we'll go back to Mechanisms. And it is smart and remembers where we left off, so we don't even have to redo all of the other stuff that we were doing, which is great. All right, so now it's showing as ID 0, front left drive. Perfect. Let's pick the encoder. The type is a CAN encoder for us. If you're using a different type of encoder hooked up in a different way, pick that. And this is our front left CAN encoder. OK, then we're going to validate the selections. So we're going to click on the validate selection block here. And it's going to do a few different tests to make sure that we have things plugged in right and that we're going to basically see where things are. So first one, the validate azimuth motor plus CAN encoder. This is going to power the module. And it is going to spin the module around. And while the module spins, what it's going to be able to do is it's going to be able to look at the CAN encoder values and see, is this wheel the one that's actually spinning? Because it can detect that with the sensor. And that it's going to use to validate that they're on the same place. And we're going to use our eyes to validate that the front left motor is the one that's spinning. Now, before you go on and actually click Start this test, you really, really, really should put your robot up in the air. You can, I think, run this test on the ground. I think it will work, but it is going to spin this motor around. And if you do get something wrong, it might spin this motor around quickly for a little bit while it tries to figure out what's going on. And I definitely did not do that and did not leave a mark on a carpet somewhere. But now we've got it up in the air. That's safer, so we can watch it. Again, double check before we actually run this that everything is clear and it's not going to, none of the motors can run into stuff. And once that's done, we can click on the Start Azimuth test. And it's going to give us a little message here, which says, hey, you got to enable the driver station before you move on. So if you remember, I'm connected through the driver station. If you're connected through the USB on the RoboRio, you will now have to run the driver station so you have the ability to enable it. So if we load the driver station up, just hit that Enable button. If it's disabled on the driver station, then nothing is going to move no matter what we try to do in the Phoenix Tuner X software. So we are now enabled on the driver station. Going back to this button, now we can click Continue. And you should see the front left module spinning. That's what we want to see here. So this is my front left. It is spinning. And I mean like the steering spinning, not the driving forward spinning. Cool. And we get a check mark because the motor that was rotating and the CAN encoder were both like in the same spot. So we were detecting the movement of the motor we expected to detect movement of. All right, let's validate the drive motor. Click Start Test. Again, it's saying, hey, make sure the driver station is enabled. I never disabled it, so we're good to go. Click Continue. And this is the same thing. You just want to look. You should now see the wheel spinning like it was driving. So I can see that. We see the drive motor here spinning, and I can see the wheel underneath also spinning. And so that looks good. Make sure that that is, in fact, the front left one that's moving. If a different module somewhere else is moving, that we don't want to see that. That means you have to go back and reset up your IDs or reset up which one is here. All right, click validation completed. All right, so for example, if the wrong motor was moving, if it wasn't front left, but say back left was moving, then what you would have to do is in here, you can go to the select drive motor and just find a different drive motor for it, or go back to the devices, right, and click the blink and make sure it's the one you expected it to be. But all of this is good. So our front left has a check mark. We're ready to move on to, I'm going to go to back left. Nah, whatever. Let's go to front right. Let's go in order. All right, and this wants steering motor for front right. So we are looking for FR steer, which is cool, right at the top of the list. And then select drive motor, FR drive. And then select encoder type, CAN encoder, select CAN device, FR CAN encoder. If you didn't rename your devices, again, I hope you have a list somewhere at least, or we could have gone through and recounted based on the order I said and just found the IDs. But this is why the name is so helpful. All right, validate selection. We are doing front right. So before I move on, I'm thinking about this. Like on my robot, front right is going to be the other side of the battery here. So I know it's going to be this module. So this is the module I'm looking at. And now that I have that like sort of mentally checked in, I can do Start Azimuth Test. I'm still enabled. I never disabled. Click Continue. And front right, the one I wanted to see spinning, is the one that's spinning. So we got it lined up correctly. All right, and that's going to spin long enough for it to read values and make sure everything is good. All right, we got our check mark. Let's do the drive test. We want to see the wheel now rotating. Yep, it is enabled. Very good. That is the right wheel is rotating. We can even see the motor on top doing it. So everything should be good there. And it finished, gave us the check mark, validate that. Now let's repeat the process, back left. So find back left steer. Drive motor is back left drive. Encoder type, CAN coder, select CAN device, back left CAN coder. Let's validate the selection. All right, back left. So this was left. This is back left over here. So we know we're set up on our back left one. When we start the test and click continue, we should see that wheel spinning, rotating. Our steering wheel going. Yep, looks good. And we'll let it do its thing. Got the check mark. Perfect. Let's do the start drive test. And I got to click continue. And there it goes. All right. So we see the right wheel. That wheel is driving. So back left. Looks like it's going to be good. We'll let it finish the test, though. And check mark. All right. Validation complete. Back left is done. Let's do back right. Click on back right. Turning motor, we're looking for BR steer. There we go. Drive motor, BR drive. And encoder type, again, CAN coder. And CAN device, BR CAN coder device 11. Perfect. Let's validate it. All right, and again, so we saw 3 of them go. The only one that's left is back right here. So we're going to start that azimuth test. Click continue. It should spin, and it does spin. Let that one do its thing. Very good. And then let's start the drive test and click continue. And we should see the drive wheel going. Yep, and we do. We can definitely see the gears up top, but I can see the wheel underneath going as well. So that looks lined up perfectly. All right. Validation completed. OK. Now, next step. We have green on all of our modules. They're all set up correctly. So now we're looking on the right-hand side with the robot configuration. First of all, make sure your pigeon is selected here. It probably will be automatically selected if that's the only IMU you have on the robot, especially, or the only pigeon you have on the robot. But double check, make sure it's there. And then we're going to click Calibrate Encoders. OK. And we got a warning here. We should disable the robot before we move on. I agree with that. Thank you for the warning. Click the disable button. All right. If you know what you're doing, you can just say, I've done this before, start calibration. We're going to click the arrow and go through all the steps. So the first thing that we want to do is we want to rotate the wheels, rotate all the modules so the wheels are pointing forward and the bevel gear is inside of the robot. So if we look, I think we can see this module over here the best. To start with. So remember, on one side of the wheel, we have this bevel gear. And on the other side, there's no bevel gear. And what this is basically saying is we want to turn it so the bevel gear is facing inside of the robot. And the wheel is pointing like forward and backwards. And since the front of the robot is over here, I want my wheel facing this way. And in this step, don't worry about the wheels being perfectly aligned. Just get them generally close. All right, so that one is facing forward and there. Let's go to the front one here. The bevel gear right now is on the outside, so I'm going to spin that one all the way around. So that one's forward. Same thing on this side. Go to front right. Bevel gear is in the middle, and the wheel is now facing forward. And then on the back here, spin it so the bevel gear is facing forward. OK, so we have things generally lined up. But it's not perfectly lined up. I think if we click the next button, so this is one thing that I think still needs to be updated in this software. This picture from overhead is, I think, the Swerve X1, so the original West Coast product Swerve, not the X2 picture. So we're going to kind of ignore this and just go on to the next step. There are a couple of things that you can do to now align the modules more accurately. There is, I think, on the West Coast Products documentation, they are talking about there is a thing that you can probably bring in from the side to help align it. We don't have that. There is another way to do this as well, and that is we can use basically a long bar going down the side. And if the wheels are both flat against that bar, then we'll know that the wheels are basically pointing in the same direction as each other. And that generally will have to be forward or sideways. So if you do the front and the backs together, that's going to work out. Now, I have a little bit of a problem because that bar is not going to fit because my wooden blocks are in the way. So I am going to move these blocks from the sides of the robot to the front and the back. So we'll move this over here. And then this one comes out, and we'll put it back here. All right, since I just moved stuff around and I'm going to power things up, I'm going to make sure that we're definitely still clear of the wheel modules, and we are. OK. So now we've got the stuff out of the way. We can get any kind of straight metal bar. So I've got this. This is a 1x1 aluminum box. Doesn't really matter what it is, as long as it's metal. You want something that's very straight. So like wood sometimes will be a little warped, so that maybe isn't where you want to start. So we've got this one. And what I want to do is basically bring it down against the wheels. And because these are the aluminum wheels too, you'll be able to feel it like on the rim. And if you sort of wiggle the wheels a little bit, you'll get them to sit flat against that bar. And because it's running all the way across both wheels, that is going to make sure those wheels are pointing in the same direction. You can kind of feel too, like if I turn this one a little bit, you can feel that as I squeeze the wheel against the bar, it sort of locks in. There's a point where it sort of like locks in and gets nice and flat. And so that's all I'm doing. I'm squeezing between the wheel and the bar on both the front and the back here. And now those are going to be pretty lined up. Let's do the same thing on the other side. Okay, so I'm just kind of squeezing them in until they're nice and flat. And I try to wiggle it a little bit just to make sure that, if it were going to move to get flatter, it would move. And then gently move out of the way. So now I think my wheels are lined up with each other and aiming pretty much straight forward and backwards on the robot. OK, so we're ready now. I guess we can click the Calibrate Encoder option here. And that will lock in the offset. So basically, the encoders are measuring like the position of the wheel. And once you click that, you can go ahead and click I'm finished. So they're measuring the position of the wheel, but it doesn't know what 0 is, right? Depending on how you attach the gears or depending on how the output shaft is mounted, like it doesn't know. And the idea is by setting all the wheels perfectly straight and aligned, then we say, hey, whatever value you're at, that's your 0 value for each of our 4 CAN-coders. Now, we use the metal bar to align all the wheels, but the more precise job you do, the less drift you'll sort of have with the robot. So making sure that the wheels are nice and flat there and everything is looking good means that your robot is going to maintain its forward and backwards movement better. If some of your wheels are slightly off, like again, if you think about it, if instead of being perfectly straight, your wheels were a little bit turned, then when you tell the robot to drive forward, it's going to slide a little bit sideways as it moves forward. So take your time, get that good. If you are driving the robot around and you find, hey, like this feels way off, like the wheels are not going as straight as I think they should be going, you can go back and you can recalibrate the encoders, or in the code you can change the values for those offsets. All right, let's go back. We are ready to continue to verification. Click on that. All right, so it is just warning us again, make sure it is up on blocks. These modules are going to all be spinning. We want them to be able to spin freely. We're going to use the driver station. We will have to enable it for the test. And yeah, don't skip these. I don't know why you would want to skip them. I think they're, they're going to find out, like, for example, if things are rotating the wrong direction, if they're rotating, clockwise when they should be rotating counterclockwise, we're going to find that and we're going to fix it here. So, like, skipping this doesn't make sense to me. All right, let's do it. We're going to verify steer first. Click on that. All right, and again, it's just extra warning us. Make sure it is up in the air, ready to go. We're going to enable the driver station. It does say, hey, like if you're in trouble, you can press enter or spacebar, and that will e-stop the robot, I think even if you're not on the driver station screen, that will work. If you do e-stop the robot, however, I think you might have to rerun both the driver station software and reboot your robot in order to like clear that e-stop flag. So if you have this up and you can click disable, that's preferable. But you know, if it's doing something crazy and you think it's going to break, definitely hit that spacebar, hit the enter key. All right, so we'll enable, and then we're ready to start the test. OK, let's click start. And your wheels should be spinning. And now it's going to ask, did all the modules rotate counterclockwise as seen from the top of the robot? If so, click yes. Otherwise, make changes. Since I wasn't completely sure what I was paying attention to, I didn't look. So we're just going to click rerun test. And basically, we're looking. So if we look from above the robot, which is great because that's where I am and where the camera is, we're looking for do they spin counterclockwise? All right, cool. So I'm going to start the test now, and I'm going to do my best to look at all of them. If you have a few people, you might want to assign one person to watch each module, or one person to watch one half of the robot, one person to watch the other half. We'll get it done, though. All right, so we're looking for, is it spinning counterclockwise? This is clockwise, clockwise. This is clockwise. This is clockwise. All right, all 4 of ours spun clockwise, not counterclockwise. So what we can do now is, in the code, basically, this is a status which is saying right now nothing is inverted. None of them have been inverted. They're all assuming it's the right direction. Instead, we're going to check them, and it's going to switch to inverted because they all spun the wrong direction. We're inverting all of them. That will make them spin the right direction when the time comes. If only some of yours were wrong, just click the box on the sum of them. Although I think in most cases, it will probably be all or nothing. OK. Then, just to be sure, since we changed stuff, we're going to rerun the test now with the inverted values. So again, we're looking for counterclockwise when viewed from above. All right, so let's click run test and then see what they do. Oh, start. OK, and clockwise, clockwise, or counterclockwise, counterclockwise, counterclockwise. They were all counterclockwise. They all started spinning the opposite direction. So now that we know they're spinning the correct direction, which is the counterclockwise direction, we can click yes. OK, and then that's going to give us a green dot here, which says steer test passed. By the way, when you're doing the test, I'll just do it one more time here. They're all going the right way. When you click rerun test, just to make sure we got this, I don't know if we were on the robot, it will kick you back out to the screen and say test failed. Just click start again. That's how you rerun the test to get the menu back up. And yes, we're good. All right, so we got the green light. When you get the green light here, we can actually go back. I guess before we go back, we will make a note. There are a couple of things that you might see. If your motors are stall whistling, that means like they're trying to turn, they can't turn, and you hear them kind of like making a kind of a screeching sound or a whistling sound. That means they're stalled and they can't move. You should check and make sure that it can rotate. Basically, feel by hand. Disable the robot. First, disable the robot, and then feel by hand. Try to turn the modules by hand. And if the modules can turn by hand smoothly and freely, then they're good. But there's a good chance that something is binding up if it's stall whistling and it's not moving, and the robot is in the air like this. Because there should be there's almost no force required to make this move. There's no resistance to it, just a little bit of friction. OK, and the other note we have is if your robot is spinning or stuttering, your battery voltage, if it drops too low, can be a problem for this. So like on the driver station, you can see I'm at 12.53, which is like a decently charged battery. Not a fully charged battery, but a solid battery. If this number starts to get into the low 12s, certainly 12.0, 12.1, maybe even 12.2, it's probably worth swapping a new battery in for this test. If it's under 12, definitely get a new battery. That battery is dead. And that's that number when nothing is happening. When things are running, they will basically things will be pulling electricity from the battery, pulling current from the battery, and the battery voltage will sag down. So if everything is driving, it might dip a little bit. But when it's just up in the air and stationary like this, it should be mid 12s or higher. All right. Then let's click the back arrow, and we now need to verify the drive. So go ahead and click verify drive. And once again, we need to make sure we're enabled. Robot should be up in the air on blocks, same things as before. And then this time when we start the test, the drive wheels should spin. All right, same notes here. We don't need to worry about that anymore. What should happen when we run this test is the wheels are going to align themselves. They're going to turn to that straightforward and backward position that we came up with. And then the wheels should drive. I think we want to see them driving in a way that would make the robot drive forward. So you can think about that. If you need to, you could put the robot on the ground and see it moving forward. You might have to stop the test early so it doesn't crash into stuff. But if you look from the side, right, the wheels should be going around in a direction that would make the robot go forward. So if I'm looking from this side, the wheel should be going clockwise to go forward. If I'm looking in from the other side of the robot, like over here, this wheel should be going clockwise as I look at it for it to be going forward. Right now, it is turned completely wrong, right? And you can kind of tell too. So like this way would be forward, this way would be backwards. But first thing it's going to do is align the wheels. So let's go ahead and do the test now. We're going to click Start. And it says Configuring Steering Motors. And then they're going to steer themselves to be straightforward or close to straightforward. And then they're going to start driving. So now you got to check all the wheels. Are they spinning in a direction that would make the robot drive forward? I saw 3 of them for sure. I think I saw all 4, but we're going to be extra careful here. So it gives us an average velocity, and it asks, did the robot move in the forward direction? You can say yes. And say OK, and you can still run the test. So that's what I'm going to do because I think it was right. But I'm going to click Start one more time. And so again, they are steering to position. And then I'm going to start on the other side of the robot over here because these are the ones I didn't see last time. And yes, the last one is definitely going forwards. All right, so they definitely, yes, all are going forwards. We're good. Test is complete. Say OK. We're going to go back to the previous page. We'll hit the back arrow up here. And now we're ready to go. So we can generate a project, or we can generate only the tuner constants. So this is, I think I mentioned this before at the wrong place. But the idea is if you generate project, it's going to make a brand new WPI lib for whatever version. This is 2025. And it will give us the whole kind of like skeleton or framework of the code with the Swerve drive stuff added in, with the constants added in. If you've already created all of that, and you have a program that's up and running, and you just want to get new values for stuff, or you have new values for this year's stuff, and you need to put that in, then you could generate only the tuner constants and use those separately. But I need a whole project, so I'm going to click Generate Project. What team number is the project for? I think I said my robot is team number 3. You should put your team number in. Say OK. Pick your language. We're doing Java. And then it just wants a place to put the stuff. So let's make a new folder here. This is going to be my test Swerve code 25. Pick that folder, and that is where it's going to put the code. All right, and I think it builds it basically instantly, but we got a few more notes here. We might need to characterize our gains. That is, the steering of the wheels may work perfectly out of the box, and it may not. The generator here is created to work for a wide variety of Swerve modules and a wide variety of potential, well, not a super wide variety, but a different number of motors could be used, or different types of motors could be used. So it's kind of hard for it to know specifically what the values are. Also, like if your robot is heavier, it's going to affect things. So there are lots of small variables where you might have to make some tweaks here. I think we'll get you most of the way there when we go through some of our testing. If your pigeon is not mounted flat, basically parallel to the ground, then you can run the calibrate pigeon, and that will adjust for that. And then if you have more questions, you can obviously look in the documentation. All right, we're going to click Open Project in VS Code. And this is going to open VS Code. You do have to have had the VS Code, the WPI Lib version of VS Code installed already with a version that matches the version of the Tuner X software that you're using, right? So we have 2025 WPI Lib. We have 2025 preview right now version of the Phoenix Tuner X. And you just have to have a match there. If you're doing 24, make sure you have 24. All right, and what do we get? Oh, yes, I trust the authors because they are me. And it's going to kind of do its initial build things. But while it's doing that, we can actually start looking at stuff. So if you click on src, that is where, that's source, that's where our files are going to be. If you click on Java, that is basically all of the program. So in generated is our tuner constants. So back in the generator, when we had a choice for create a new project or just the tuner constants, this is the tuner constants. And this is the bulk of what is created here. If we go into this tuner constants, we can we'll look at it. We're not going to cover everything, in detail, but we're going to point a few things out. So as we scroll down, and it is commented too, which is very nice and very helpful. So also, before we continue, let me make sure my robot is disabled. It is. Cool. So first thing here is in the tuner constants, we have gains, steering gains. So this is, like I said, there is a control algorithm that will tell the wheel how to turn to get to the right position. And it's not as easy as just saying if you need to turn to the left, and if you need to turn to the right, turn to the right. That actually would work, but would be generally pretty slow. And you don't want that. You need these wheels to steer quickly. Because if you're driving forward and then you want to start going to the side and you hit sideways on your gamepad, you want that to happen relatively quickly. You don't want to be like turn to the side and the wheels are like, I'm going to get there and I'm going to stop at exactly the perfect point. But it took 2 seconds to get there, which means you can't start going sideways for 2 seconds. So what it's going to use is it's going to use basically a bunch of configs, gains, in order to make this happen better. And there are a few different gains that are here. We're going to be using a PID, but also with KS, KV, and KA. The idea is to think about it this way. There is the proportional error is how far away are you from where you're trying to get. So if you're pointing forward and you want to be pointing sideways, maybe that's really far away. That's 90 degrees away. If we say however far you are away, we're going to use that as a scalar, a multiplier for how fast the wheel should turn. So if the wheel's really close, we can move a little bit to get to the right spot. If the wheel's far away, we're going to move fast to get there quicker. And then it'll slow down kind of as it gets close. So that's kind of what the proportional stuff is doing. I don't think we're going to try to explain to you all of PID, but in general, the D term is going to help slow it down. So if it's approaching too fast, the D term will kind of help stop it from overshooting. And we're going to play with these in a little bit. So we're going to get a little bit more of an in-depth look at how we might have to tune these if the values that it gave us here don't work the way that we want them to. If we scroll down, the next one, this is drive gains. So this is moving the wheels, driving the robot forward and backwards. You can continue to build on this because there are sensors in each Kraken motor. So in addition to the CAN coders, inside each of the Kraken motors, there is a sensor that will basically be able to tell how fast the output shaft is spinning or how many times it's spun. So we can use that to actually control the velocity of our robot. We can know how fast the robot is moving velocity-wise. And if you want to do control based on velocity instead of just sending it, go forward fast or faster, that is possible. And so these are the gains for velocity control. If you're not making any changes to the code or intending to use that, it's not going to be a problem for you. You don't have to worry about tuning those. And you can see that it basically set up a lot of stuff. So it's going to configure the Talon FXs for us. In here, we have current limits. So actually, in two places. So up here, we have K-slip current, magnitude of 120. So this is the drive motor current limit at 120 amps. And then down here, this is the steering current limit of about 60 amps. And those are pretty good values to start with. If you end up running into some trouble where you just have a very power-hungry robot and you need to limit the drive a little bit more, you might have to come back in and change these. You could probably fine-tune them a little bit more, but these numbers are going to serve you pretty well. OK, what else have we got? You can see we're on our Canivore 1 CAN bus. And then down here, all of those ratios we chose, like when we chose the module that we were using, and we chose the gear ratios that we were using, that stuff is all here. So that K-drive ratio of 6.48 to 1, that's based on me using the X3 ratios with the 10-tooth gear, which means I was using the 16-tooth and the 10-tooth. That gives me 6.48 to 1. We have a steering ratio, which it just knows because the steering ratio on the Swerve X2s are always fixed at 12 to 1. So it's able to put those things in for us. If you're using a custom Swerve drive ratio, you would have added the custom values in when going through the tuner. And then we have invert left side, invert right side. When we try to figure out was it driving straight forward or not driving straight forward, that is where those values got put in. Pigeon ID, what else in here is kind of important or interesting to look at? Not too much. Then we basically send all of the values over, come down. You can see now each module has a little section here. So we have front left. It gives us the CAN ID 0 and 1 for drive and steering motor, and then the encoder as well, the CAN coder that we're using. And then below that, you can see here, this is the encoder offset. So when we went and we lined up our wheels straight, and I told you it was going to read the value, and that value was going to be like the new value for going straight forward and straight backwards, that's what's showing up here. So we can see, like for the left front, we were very close, just 0.1 off from center, but front right was negative 0.33 off. So each one is going to have a different value there. Then did the steering turn the wrong way? If it did, this is where we flip it. So that's why we got a true here. It is inverted. And then the CAN coder values, did they need to be flipped? And nope, those are good. And then when we chose the size of our robot, where we said it was 23 inches from module center to module center, that is where we get this 11.5 from. Because if 11.5 times 2 is 23. So this is to the center of the robot in the X direction to the module, and from the center of the robot in the Y direction to the center of the module. Since we were square, numbers are the same. All right, and we have those values for front left, front right, back left, and back right. So if something is off or one of the encoders is off and you have to go and find a new value and you just want to type it in yourself, this is where those values are going to live. OK. I think we're kind of ready to go ahead and test this. And we can test it up in the air, but know that when nothing is on these modules, they spin very freely, right? If we put it on the ground, now it has to kind of drag through the carpet to be able to turn. If I had a bunch of weight on top of the robot, like if I built an entire robot instead of just kind of a base, a drivable base, then even more weight is on them. It's going to be harder for them to turn. So the values that we try right now with just this test bed that's pretty light may not be the values that work best for you after you have built your whole robot. But let's see what happens. So if we go to our driver station, we are going to do a couple things. The first thing is make sure your team station is blue 1. So I guess WPI Live has decided that the field is basically oriented from the blue side. So the 0, 0 coordinate on the field is going to be in the corner on the blue side. So if you are trying to check your robot out and it feels like it's driving backwards, double check, make sure it's not set to red 1. I think this will default to red 1 when you run it for the first time. So we want to be in blue 1 to make sure stuff works out. We'll talk a little bit more about that in a bit too. Okay, and we're going to enable, but before we enable, we need a gamepad. So let me grab one here. And we'll plug it in. And it's like I'm going to be using a genuine Xbox controller. The Logitechs work fine as well. If you're using Logitech controllers, just make sure that the switch on the back is in the X position or Xbox emulator mode. Otherwise, I think D could do weird things. OK. I would say, though, that if you have some extra money, typically the Xbox controllers do a little bit better job. The potentiometers inside read a little bit more consistently. So you might find a small upgrade by switching to a little bit more expensive controller. All right, so now let me make sure that is hooked up. I'm going to go to the USB thing. OK, I got my controller. It is in port 0. That looks good. OK, so let's enable the robot. And when we enable the robot, I'm not really going to touch anything, but ideally, the wheels should find straight forward and stop moving. And then we should be able to try commanding the wheels to different angles and different movement velocities. So let's enable it and see what happens. OK, we're enabled. I think because all of our wheels are straightforward, it didn't have to move at all. So what I'm going to try doing is just gently push forward. So OK, wait, before the setup here is on the gamepad, forward and backwards. On the left joystick is going to sort of be forwards and backwards on the field. So this is set up for field-oriented control. So right now, this is the front of the robot. which means we have now decided that in our room, this direction is forwards on the field. So if you ever press forwards on the gamepad, that is going to make the robot move in that direction, regardless of which side is facing forward. Because, of course, we started right now set up in this orientation, that does mean the robot also will go forward. But if we rotate the robot later and we press forward on the gamepad, it's still going to move in that direction. Okay, then that means left and right on this left side stick here is going to command the robot to move left on the field or right on the field. And then backwards will make it move, backwards on the field as well. Then to rotate the robot, the second joystick, the right side joystick, is going to control that. And that's going to work by going left and right on that joystick, is going to rotate your robot. Okay, and then the left bumper will reset the orientation of the robot. And we'll talk more about that once we have everything working. So once again, I'm going to enable. And if I push forward on this joystick, because my wheels are aligned forward, we should just see the wheels turn. But the steering shouldn't move at all. Let's try that. And nothing happened, and I know why. I'm going to disable the robot. So remember when we were in tuner here, and we did the whole, in settings, we did the whole run temporary diagnostic server. That's still running. Our code is not running yet. And we have to download the code. So back to WPI Lab. All the code is here, but it's only here on the computer because it got generated. It hasn't been downloaded. When we download it, that will also reset the RoboRio and clear out the diagnostic server. So to do that, if you click on the sort of WPI icon here in the corner, we want to choose deploy code. If it's not showing up, start typing it. It should show up. You can click on it. Or use Shift F5 if you want the shortcut. All right, that is going to now build our code. And then it will deploy it to the robot. I got a little ahead of myself here. I was in a hurry to start driving. All right. And once this stuff kind of pops up, we're good. I don't think I need the real log here. Let's go to the driver station. OK, and now it looks good. OK, yep. So now we're ready to repeat the test we did before. So I'm going to enable it. We're going to see what happens. I'm going to disable it because that's kind of loud. So what just happened? Nothing bad. The wheels are all generally pointing forward. And your robot is probably doing something similar if you are using the same kit. The wheels are all pointing forward. But what they were doing is they were oscillating back and forth. So the wheels were like sort of twitching a little bit around the set point of pointing forward. That means that I think our values, our gains, are maybe not tuned perfectly for this robot. Let's try to do one more test before we go in and mess with the values. We want to see if we can get the wheels to steer. So if I try, for example, taking the gamepad and aiming to the left, it's probably still going to be jittering back and forth like that. But instead of jittering back and forth around the wheels facing forward, it should be doing it around the wheels facing sideways. And if we see that, we kind of know things are working. And then we can move on to start trying to tune our values in so it's a little bit more stable. And the other thing we'll check, too, before we change any values is run it on the floor afterwards. But let's make sure it passes this next test. All right, so I'm going to enable one more time. And once again, you can see they're staying generally forward. I'm going to push sideways now on the controller. And you can see, I can't even hear myself. They did spin sideways. And in fact, as I pushed sideways farther, the wheels started driving. So, and it was to the right. I think everything was correct. I think they turned the way we wanted them to turn. They spun, I think, the way we wanted them to spin. It was hard to tell because so much noise and things were happening. But when we told it to turn sideways, it turned sideways, which means I think like all of the directions are correct. All of the code was generated correctly. The only thing that we're dealing with now are the gains. And if you're doing this, especially if you're doing this on a slightly different setup, if you're not using exactly what we're using in the kit, you might get similar but different responses. It's very easy for incorrect gains or a mistuned or untuned PID to look like lots of things are broken when in fact it's just the gains. So before going back and saying maybe something went wrong and I didn't generate stuff correctly and I'm going to go back and I'm going to go back to the Swerve generator and start over and do it all again, you probably are going to want to work through tweaking these gains and seeing if that's going to solve your problem first. If you can really watch what's going on, like I said, when I was looking, and I've had a decent amount of practice looking at robots and Swerve wheels doing these kinds of things and having to tune the values in. But when you see it sort of like oscillating back and forth, but it's doing it around the point that you think it should be pointing, right? Like at the beginning when we just turned it on, it was going back and forth, but it was doing it mostly pointing forward. That's a good sign for me, because that means it's like it's trying to point forward, it's just it's overshooting. It's going too fast and then it has to go the other way, and it's going too fast and it has to go the other way, and it's going too fast. If instead what you saw was the wheel not oscillating back and forth, but just spinning forever in one direction, that's a sign that something might be backwards. So for example, if the wheel is pointing in this direction and it needs to go to this direction or to this position to be where it wants to go, but it turns the wrong way, it's never going to get to that position. And that's why you might see something spin forever, because it's turning the wrong way. And so that might be a situation where either the wheel, the steering wheel motor, or the encoder actually needed to be inverted. If you run into that problem, it might be worth going back to the generator, running it again, and making sure that when it was supposed to spin counterclockwise, it was actually spinning counterclockwise. You can also, we talked about where those were in the tuner constants in the software. You could try flipping those on your own, from true to false or false to true, in order to see if that helps out. But anyway, we're ready to probably put this on the floor and then start trying to tune in our values to get it a little bit more controllable. All right, so we've moved our desk out of the way a little bit, made some more space over here for the robot to be able to drive around. And our goal here is we're going to run it kind of with the values that we have, the gains that we have. And we want to definitely try it on the ground, because we talked about it earlier. When it's up in the air, there's no weight pressing down on the wheels. So the gains are going to be different if you do it up in the air versus if you do it down on the ground on carpet. That's another thing. If you don't have access to carpet, you might want to even just get like a small on sale area rug, like a, whatever, 3 by 5 is maybe the smallest you can get. I don't know. But something that the robot can sit on, even if it doesn't move, you can use that to check these values and tune them in. It will be different tuning it on a hard floor, because on the hard floor, the little treads on the wheels aren't going to grip in as much. So it's going to be easier for the wheels to rotate. When they're on carpet, they'll dig in a little bit more. The robot will sink down. It's going to take a little bit more force to make the wheels steer. So we're going to basically try this on the ground and see how it behaves. See if it's still overtuned. We saw it like twitching back and forth, right, when we had it up on blocks. Let's see if that's still the case when it's on the ground. But we're also going to try to verify. We did that forward and sideways test to see how things were going, and that kind of worked out. We're going to see if we can get the same thing to happen on the ground and make sure that everything is working and it really is just a matter of getting the tune right. Now, there's one thing that I want to do really quickly, and that is, remember, whatever position we start in is that's going to be the position it thinks is forward and backwards. And since I'm going to be standing over there and the battery is the front, I'm pretty sure I want this to be facing this way when we start. So that I don't get confused in my brain and drive into something. All right, so that's pretty good. And another thing that we can do is, I'm not going to reset the robot. If I rebooted the robot and everything booted back up and the program started running, it would default to the position that it's set in as the starting position, as the 0 position. But we can also hit a button on the controller, which will do the same thing. So if we go ahead and enable the robot, if we go ahead and reconnect to the robot's Wi-Fi, somehow we disconnect. There we go. All right, we're reconnected again. First thing to check, of course, anytime you have robot problems, if it doesn't have communication, make sure you're on the right wireless network. All right, let's enable that. OK, so something else I can do instead of resetting the robot if I want to reset its orientation. And this is something that you might need to use during the match. If let me disable it because we got some chatter going on here. If your robot slowly drifts and loses position. Like if you push away from you and the robot is moving on a little bit of an angle, that can happen sometimes, especially if you get in some big hits. The gyro can lose track a little bit of its position. If you hit the left bumper on the joystick that's built in this default code, that will reorient it. So if you can make the robot be facing away from you, or whatever your starting position was, and hit that button, it will reset it, and you'll be good to go again. All right, so back enabled. We can hear there's some chattering. It's not as bad on the ground as it was in the air, of course, because we have a little bit of weight on those wheels. I'm going to try driving around and see what happens. So if we go forward, looks like the chattering got a little worse. But you can see forward is going forward. Backwards is going backwards. Let's try left. Left is going left. Right is going right. And that's pretty good. We're losing a little bit of our initial aim because of the chattering, sometimes the angle's not exactly right. All right, let's try rotating. So I'm going to use now the right joystick, and I'm going to try to rotate in place. All right. And what's cool is, of course, if we're rotated a little bit to the side, if I press forward, it's not going to go towards the battery. It's going to keep going the direction, facing away from me. So it should go the same direction that forward was going before. So in theory, we should be able to go forward and rotate at the same time, and it will keep tracking on the direction that it was moving. All right, so this is kind of working. Let me go ahead and disable it here. It is a little loud with the gears chattering. So this is working, but I think that our gain values are a little bit wrong. They're a little bit not tuned correctly. So I'm going to show you how I would kind of look to at least get a decent set of tuning values or gains for the robot. And the robot is going to kind of sit in place. We'll use the Phoenix Tuner X software again. You can actually directly connect to the steering motor and play with the values to make it turn back and forth. But one thing that I will warn you about is when the robot is sitting in place and the wheel is spinning, especially if you throw in some gains that are way off, the wheel might spin very fast, might spin back and forth a lot. This can wear on the patch of carpet that you're on. And since we are borrowing this room, I'm going to throw down a different area rug, like a weather mat when you come inside. So I'm going to throw that down and put the robot on top of that. It's not ideal. It's not perfect because the carpet that will be tuning our values on will be a little bit different than the carpet that we'll actually be driving the robot on. But it's going to be close enough, and it's going to not force us to replace the carpet in the room that we're in, which is a good thing. All right, so let me go grab that carpet, get the robot set up on it, and then we'll jump into tuning gains. So we have the robot now on top of an area rug, so I won't damage the floor here. And we're going to go ahead and try tuning one of the modules. And in this case, all 4 modules, technically, if you wanted to do it perfectly, you could tune each of them separately, get different gain value. It's going to be fine if you just tune one and set them all to the same thing. So the way we're going to do that is we're going to jump back into the Tuner X software and get to the device page. And you can pick one of the steering motors, your choice, doesn't matter. Looks like front right for me is facing the camera the most. So I'm going to find front right steer and open that one up. And some of the other tools that we have available to us here in the tuner software is we can go to config instead of info. And on config, first of all, you can set current limits and stuff here. I think these will get overwritten if you have something different in your code. But if we scroll down to slot 0, this is pulling the gains from our program, or has the same gain set that our program has. So 100, 0, 0.5, 0.2, I don't know why it's 0.200195 through, it's fine, it's close enough, and 1.5 for KV. So we're going to be able to change these numbers here and see how it affects the movement of the steering of the wheel. All right, on the other side, if you go from self-test to plot, we can actually track the position values of or the positions of things, or a whole bunch of other things. We have acceleration here, velocity. What I want to do, though, is I want to scroll down and find PID position. So PID position is what we're working on. PID, again, proportional integral derivative. And in PID position, we have a few different things that we can check. So first, closed loop error. The closed loop error is essentially the position that the sensor is currently in, minus the position that it wants to be in, the goal. So it's basically the error of where it is to where it wants to be. So we can watch that. And if it goes to 0, that means we're pointing where we want it to be. So our goal is to get this error down to 0. We can also do reference. You can check reference or not. If it confuses you to have 2 lines, reference is the less important one to have. But this will just be the absolute value of the CAN coder coming in. So if we check those 2 things, what you can actually do is if I hit play, you can see the reference right now, our error is basically 0, and our position of our camcorder is about 0.43. You can always hover over it to kind of get those values. Now, on the bottom, we have the ability to enable control of the motor here. If you don't see all of this stuff, you can click on this pull down, and you can choose from all of the things that we have here. Which one do we want? We want to go to position voltage for this test. Okay, and don't worry too much about any of the check marks here. They're all fine. But what you can see on the right-hand side, we can give it a position to go to, and then if it's enabled here and enabled on our driver station, it will use our gains in slot 0. Actually, if I scroll down, it'll show you it's using slot 0. I could actually put gains in slot 1 and gains in slot 2. So if you want to keep some backup gains and not lose them, you can store them somewhere else here, or just write them down with a pen. So slot 0 is what we're using, and that's where we left off. And let's see. So what we want to do is enable the robot, and then enable it here. And if I give it a position to go to, like a good position might be like, let's do -0.5. -0.5, and hit apply. And what we'll see in this area, let's see, we can, actually let's clear this plot so we don't have all the extra stuff. So when we go to 0, if I pause this, we can look at what it did. So remember, the blue is our error. So we started with a big error here. Once I gave it a position to go to, this is where it got the position to go to. It tried to get there. It overshot a little bit. It went too far, went back a little bit too far the other way, but ended up pretty close to the right number. But one of our issues that we have right now is, so this kind of works, but you can kind of hear my robot is chattering. If yours is doing the same thing, then you might need to make this change too. But it's kind of chattering back and forth. One of the things that I think we're looking at is this KS value is a little bit too high. So your version, actually, you might be like, why is your KS 0.2? You might have a completely different number generated automatically from the Swerve generator. Again, we're working on the pre-release, the beta version, so some things might be a little bit different. I think we're going to set this number down to 0.1 and work from there. And I close slot 0. And when we go to tune things, we want to basically use this chart that I just showed in order to sort of tune the values in to find what we want. And I'm going to go ahead and take KD down to 0. And basically the way to think about it is your KV and your KS are kind of calculated. KV is based on the motor you're using, and KS is based on the motor you're using, but also and the robot, the kind of the gear ratio of the robot that you're using. So there's a little bit robot-specific stuff in KS. KV is completely based on the motor, but these are sort of calculated values. So when you have them, you shouldn't have to mess with them. KS, you might need to tune if things are really not working well, but it's a little bit tricky to tune, so sticking with the default value, or if you try all this with the default value, you can try it with 0.1 like I'm doing. The default value might be 0.1. I'm in the past, you're in the future, so you know more than me. But try it with those 2 numbers first before you start tweaking it. All right. Then the next thing we want to do is sort of pick a KP, and we want to choose a KP that's going to overshoot a little bit. We want it to be a little bit too aggressive for KP. And then what we can do is use KD to sort of bring that back under control a little bit. So 100 was the default generated KP, so let's just start there. I'm going to go ahead and enable stuff again. Oh wait, when you change the gains, you need to click this button right here to apply and flash configs. That will actually update the config values on the motor. All right, and then let's go ahead and enable on driver station, enable here. And one of the things that you might need to do is if you're running into problems, if you're doing this and it feels like the things are working not how you would expect, you may want to come in and go back to the settings page and run a temporary diagnostic server. It should work without doing that, but depending on what your code is, you might get other wheels moving or other wheels moving in response to the wheel that we're testing moving. So if you see more than just the one wheel that we're trying to tune rotating, you might come in here and do the run diagnostic server just to take care of that issue. All right, I'm going to jump back into my front right steer motor here and go back to the plot. Oh no, it forgot. All right, I'm going to pick it again. PID position and closed loop error and reference. OK. And then back to config. The config, I think since we downloaded it, saved it. All right, it changed the 0.1 to 0.0996, whatever. That's fine. I'm not worried about that. OK, and we're going to go to, like, let's try 0.5 this time. All right, so now we have just the KP. We have no KD. We have no KI. I definitely would recommend never changing KI unless you really know what you're doing. All right, let's hit play. And oh, wait. There we go. OK. So we could see what happened here was that went. If I pause and we can sort of look at what's happening here. So you can see it overshot and then overshot again and then overshot again. So this maybe is slightly too high. We want to try to limit the overshot. We want it to overshoot a little bit, but maybe not quite by so much. Let's try jumping down a lot. Let's try like 80 here and see what happens. Okay, click the button to reconnect, and then we can try again. So I'll go to, I have to actually play. Sometimes I'll clear the plot too. All right. Let me see here, reset, and there we go. All right. If you get into trouble, you just reset the zoom. I think I zoomed in on something. All right, so let's hit the button, and then I'll pause it. All right, so that is better. As far as the overshoot goes, we can let's try going way down to a very small number just so you can kind of see what happens maybe if we're too low. So let's try like 10 and see what happens. All right, and all right, so that's good. That's good. That looks way different. So what's happening here is it is taking forever to try to get there, and even at the end of the plot, like even if I go here at the end of the plot, it basically got there. But the KP value is too small. You can see how long it took to get there. This is what we were talking about at the beginning, was like you could tell it to slowly turn until it's in exactly the right position. That will work, except like look at how long you have to wait. It's like 2 seconds you have to wait, or over a second you have to wait before you can change directions. That's not what we want. We need it to respond faster than that. So we can try, again, increasing this. Let's go to like 50 and see what that looks like. And let's see, clear, play. And that's actually that's not terrible. It overshot a little bit. And then it actually didn't go back on the other side. I think we kind of want this to go a little bit back on the other side. We want to be a little bit more aggressive here. So let's jump back up. I actually think like our initial number was not far off. Let's go and try like 90 and see how it looks. Let me reset or clear the plot. Let's see, did I send it? Let's try again. There we go. And that I think that is, let me stop it from, we got some of the other wheels still jittering back and forth. That's pretty close to, I think, what you want to see. So like we overshoot a little bit and then overshoot a little bit back on the other side and then sort of find our way in. And the idea is we want to be a little bit too aggressive right now for the KP value, because when we add KD sort of stops, it opposes the motion. So like it will, as we approach too quickly the set point, it will try to slow us down a little bit. So that should knock these ridges down a little bit when we add some KD. And let's see, we'll try, I don't know, we'll try like 1 on KD here and see what that does. My guess is this is going to be too big, but we'll see. All right, we'll send it, and then start tracking again, and see what happened was I disabled the robot because of the noise. All right, here we go. Kind of 2 examples there. And you can see, well, I meant to pause, not the other one. You can see it is overshooting, but it's not really overshooting again on the other side at all. Let's get one clear example here. All right, it's slowly kind of working its way in. So I think, this is actually probably not terrible. I think probably if you tried to drive your robot around like this, it would probably work. Let's try reducing this down a little bit to like maybe 0.5 and see how that goes. Okay, and what you see here is, it's a little hard to see, but it is kind of bouncing around above the set point instead of getting to it. And I think usually sometimes you see that as a sign that the D value is still a little too high. We can try one more time here. Let's run it again and see. Sometimes you want to check a couple times too. Sometimes you want it to run in 2 different directions as well, so you can see what's going on. But yeah, you see we get a little bit of that wiggling back and forth there. I think I'm going to reduce the KD again a little bit. Let's try 0.2 and see what happens here. All right. We got to upload our config. OK. Let's clear the plot. That seems pretty good. So we go above and then just back to the other side, and then we kind of park in there pretty stably. So this seems pretty good to me. I think what we can do now is we can take these numbers. So we have KP at 90. I think it was 100. So we reduced it a little bit to get down to 90. Now what's interesting is on your robot, especially as you add weight to it, there's a good chance that 100 is going to be closer for you. Because remember, this is just a chassis. I would estimate this thing at like maybe 40 pounds. Yeah, something like that, maybe 50. Full robot is like 120, and then the battery is extra and bumpers are extra, so you're going to weigh 3 times as much as this robot. There's a really good chance your p-value will need to be higher when you have a full built robot with all the weight on top. So reducing it a little bit makes sense to me. And then along with that, reducing the KD does not seem crazy. So I think these numbers are a pretty good place for us to test again, do a full robot test. So in here, I'm going to go ahead and disable this. Really, I think we're done here, but we want to make sure we remember those numbers. So 90.2, and we left the other things alone. OK, so if we jump back to our code, find the gains, I'm going to change the 100 to a 90, and the 0.5 down to a 0.2. And then for KS, we're looking at 0.1 instead of 0.2. All right, that looks good. That's what we want to try. So we're going to go ahead and deploy the robot code again. And while that's deploying, I'm actually going to move that mat out of the way because we're not doing the testing anymore. Or the tuning, where it's going to be in the same place spinning. So we'll go back to being able to drive on the carpet that we've got over here. All right. Let's see, I think we're up. Let's go back to the driver station and enable the robot. So right off the bat with those new gains, especially with the KS value down to 0.1 instead of 0.2, and the P value down a little bit to 90, it's not chattering back and forth. And even if I like move a little bit, it's like getting to the position and then it's kind of static. It's getting there. We don't have this back and forth oscillation, which is what we want to see. We kind of want your goal with this robot is you want it to turn to the correct angle as fast as possible and not oscillate afterwards. That's like the ideal situation, right? Because the faster it turns to the right angle, the faster your robot responds to changing inputs, changing directions. But if it's oscillating back and forth, your robot is going to wiggle. It's also, not quite going to be stable and also loud also. But all right, let's test it. Let's drive this thing around. So forward, backwards, right, left. That's looking good. And turning and moving. And you can see it still does take some time, right? Like if I'm going forward and switch to sideways, it's still going to take a little bit of time for it to adjust. But this is, like, you can just kind of feel it. And that's, I think, what you should expect, right? Because nothing can turn instantly. OK, there's one more thing I'm going to show you, and that is every time I drive this robot around in this area, I am sort of just bumping the controller and then immediately stopping before I crash into stuff. So if you have a small area like I do and you want to be able to kind of drive the thing around a little bit more or for a little bit longer, and it's hard for you to kind of keep the robot slow by going slowly on the joystick, we can make a change in the code to sort of scale the speed of the robot down, which you might want to do. You probably don't want to do that when you're on a big first field, right? Because remember, our first field is like 54 by 27 feet. And I would say the room that we have in here is maybe 10 by 10. So we're like a tiny little fraction of that. So we don't really ever need our full speed here. But if we go into the code, I think it's in robot container. Yeah, so if you go into robot container and scroll down just a little bit, we're looking for configure bindings. And then we have drive. So this is sending the drive command. And we're reading the values in from joystick X and Y. Left X and left Y. And then we have the right one. So I'm not really worried about changing the rotation speed right now. But what you can think about is if essentially what's happening here is we're taking the joystick value, which is a value from -1 to 1, and multiplying it by the max speed of the robot. So if we push the joystick all the way forward, it's going to be 1 times the max speed of the robot. We're going at max speed. What I can do is I can take this whole thing and divide it. So if I divide by 2 here, what that's going to do is that's going to take the max speed of the robot and, well, it's going to take the joystick value, and instead of sending 1 times the max speed of the robot, it's going to be 0.5 times the max speed of the robot. So we're moving at half speed, or however you want to think about it. I think in this space, I'm going to do divide by 3, just to really slow it down so I can get a good feel for driving around and rotating and making sure everything is smooth and working the way I want. Again, do this if you're testing in a small area. If you got a big area, if you got a whole field, just go out there and let it rip. All right, let's download this. Almost there. All right, and we get our driver station up. We're going to have to re-enable once it is good. All right, enable. OK, so now if I push forward all the way, it should be like when I was being gentle with it. Yeah, OK, that's. So now if I try to go slowly, I can go very slowly. Just a little bit easier. Obviously, if you have a lot of touch as a driver, you don't need to change this. It's going to be fine. But yeah, OK. So always, if I push forward, it always should be going that way in the room. Yep. And no matter which way I'm facing, if I push backwards, it's going to go back towards me here. If I push forward, it's going to go away out and towards the middle of the room. Cool. And no matter which way I'm rotating, like, again, now the front of the robot is facing away from kind of the wall where I am. And if I go backwards, the robot should still go backwards, OK? And forwards is forwards. But then if we do a 180, now if I press forward, right, it still goes that way in the room, not the direction that the robot was going. So that is the field-centric control. And that feels good. Everything feels like it's working well. And switching from forward to sideways, like I'll try to do a little square. Yeah, and that feels good. That feels very responsive. The steering is quick. It's not oscillating. I can feel it like locking into a position, and it's generally going where I expect it to go and want it to go. So I think those are pretty good values, but remember, those are pretty good values for my robot, which is light, which is these specific modules with these specific ratios. The good news is if you're using any of the Swerve X2 modules from West Coast Products, your steering ratio is going to be the same. So even if you're using a different robot speed. If you're using, instead of the, what do I do, 6.48 or whatever to 1, where I use the 16-tooth gear and the 10-tooth gear, if you use the 12-tooth gear, your robot will drive faster, but the steering is going to be the same. So actually, the PID values that we kind of tuned in here are going to probably work pretty well for you. And there's a good chance that just the default values were working fine, and that's okay as well. Just know that that is the process to go in and kind of tune it. After you tune it in Tuner, then I like to dump the values on the robot, drive it around a little bit, and see how it feels. And you might have a couple of different values, and you're not sure which is better. Go ahead and try driving the robot with one set of values, drive it with the other set of values, drive it with a third set of values. And honestly, if the driver thinks they all feel the same, doesn't matter which one you pick. If the driver thinks one is definitely better, that's the one to go with. All right, so I think this is completely working. And we have a functional Swerve Drive robot. All right, so that is it. We've got everything running. We can drive our Swerve Drive robot around. If you're looking for maybe some additional tips, maybe autonomous mode stuff or integrating other things into your Swerve Drive system, definitely check out the documentation. Cross the Road Electronics has a lot of information out there on how to do stuff. And there are other examples out there as well. We do hope to come back and do an autonomous mode with the Swerve Drive robot video. That will be a little bit later. So hopefully we'll see you at that one as well. And I guess we're set for this series. But before we go, one more special thanks to Argosy for making this all possible, to our product sponsors, Cross the Road Electronics and West Coast Products, and to our hosts, Team 302, Lake Orion High School.